Hello, today I'm going to show you how to align a pinhole. We have here a pinhole wheel, and using a post and a post holder, we have mounted the pinhole wheel onto a translation stage. This stage gives us the flexibility to move the pinhole wheel in the X, in the Y, and in the Z direction. When you position the pinhole wheel, you want to make sure the tilt of the pinhole sits vertical. So this means there isn't a tilt forward or a tilt backwards. You also want to position the pinhole wheel where the beam converges to the smallest point. And of the two beams, you want to make sure one of the beams is filtered through the pinhole. And by doing this, rotate your pinhole wheel to the largest pinhole size, which is 2,000 micrometers. And make sure one of your beams is filtered through that pinhole. The other beam is either going to be blocked by another part of the pinhole or off of a skewed edge of the pinhole. And to check, you want to block the beam that isn't filtered through the pinhole, and you want to make sure the beam that is filtered through the pinhole is centered with respect to that beam that's filtered through. And to center the pinhole, you move the pinhole in the X and the Y direction. Another thing you want to check is to make sure there is uniformity of these two beams of light. You don't want one of the beams to have a spot of light. You want a uniform and consistent beam of light. You also want these two beams to have a similar intensity of the light. And to change this, you move the pinhole in the Z axis. Now to align the pinhole, let's start by moving our pinhole to the largest pinhole size, which is 2,000 micrometers. And all you want to do is make sure the pinhole is centered with respect to the beam. So again, you move the pinhole in the X direction and in the Y direction to get a uniform beam of light in both of these beams. Also, you want to have a similar consistency in the light. Once you have done this for the largest pinhole size, continue to reduce your pinhole size until you reach the smallest. To center it, again, move the X and the Y to give you this uniform beam of light in both of the beams and a similarity in their intensity of the light. Again, rotate the pinhole to the next smallest pinhole size. If you already have this uniform beam of light, continue to reduce the size of the pinhole. And we're here at 200 micrometers here, and we need to move the pinhole to center it. Again, this is here at 200 micrometers. I'm going to move it a little bit to center it. And again, you don't want the spot of light. You want the uniform light. as we have here. Continue to reduce the pinhole size down to 125 micrometers. Reducing to 100 micrometers. Now to 90 micrometers. Now to 80 micrometers. And this is a very tedious process, so take your time. The smaller the pinhole gets, usually the more trickier it is to align it. So again, take your time. Down to 70 micrometers. Now 60. Now 50 micrometers. Now down to pinhole size of 45 micrometers. Excuse me, 45 micrometers. Now to pinhole size 40 micrometers. Now to pinhole size 35 micrometers. And again, the smaller the pinhole size get, the more trickier it becomes to align. So take your time. We're here at the 30 micrometer pinhole size. And lastly, we have the 25 micrometer pinhole size. Again, take your time. These smaller pinhole sizes are really tricky. Lastly, the 25 micrometer pinhole size. And once you've done this, you'll be able to filter in the frequency spectrum, and you will be able to produce one beam, a uniform beam, without the object replica.